Good afternoon. Good afternoon. Hope all is well and everyone's doing all right.
Hello.
Hey. All right. So let's see. We stopped right here last class. Did orthogonal. Okay, this is where we stopped. All right, so let me see if everybody's connected before we get going. So, hope everybody's doing great. Everybody's doing all right. We're looking to close out chapter 7 today. Hopefully, I believe we can close out chapter 7 today. This is 7.7 that we're in. Remember, we finished off 7.6 last class. Then we got into 7.7. Did not finish it. So we're looking to finish off 7.7 today. And then that would be the last section for chapter 7. And then we talked about how next class we will be looking to review, just answering questions if you guys have them. And then the day after that, well, next Thursday, I'm going out of town. And then when you guys come back, that's when we'll be looking to do that proctor test. So we'll talk about that in a little bit more, but let's go ahead and knock out 7.6. So we're looking at the projection of a vector onto another vector. Trying to write some of this a lot more neater. So a method used to find the components of force. That is applied is to project a vector onto another. All right. So the notation here, we have project, it's P-R-O-J, and we have a subscript W, and then a vector V. So that W should be a little further down. All right. So that's vector projection of V onto W. And then here's some diagrams of how that force can be applied. Make a little more sense when we put a word problem to it. And so here I was explaining how force is applied onto the boat. You know, gravity is coming down on us, but if you're trying to, let's say you're trying to drop the boat off on, you know, how you drop it into the water, it's going down the ramp. You know, there's force that's coming down on the boat in that slanted direction going down the ramp, but then there's also force being applied onto the boat, on top of the boat. So this is how we'll be able to calculate all that type of, I guess you would say, good stuff. All right, everybody still holding on to the diagrams? All right, so the vector projection of V onto W. So you have the dot product of V and W over the magnitude of W squared times W. All right, so let's look at an example, trying to calculate this vector projection of V onto W. So if V is equal to 2i plus 4j and W is equal to negative 2i plus 6j, find the vector projection of V onto W. So just like before, when we do our calculations, you always want to look at the pieces that you can find and then put them into the formula. So, you have the dot product of V and W, the magnitude of W squared, then of course you have W right here. So you have your three pieces that you want to, implement or calculate. So the first thing you find is the dot product of V and W. Excuse me, I just sneeze. All right. So you know that this is A, let's call this A1, B1, A2, B2. So you got A1, A2, B1, B2 for the dot product. So A1 times A2, A sub 1 times A sub 2, 2 times negative 2, B sub 1 times B sub 2, 4 times 6, so that's negative 4 plus 24, which would be 20. So that's your dot product. So then the magnitude of W squared. So the magnitude of W is what's on the inside of the parentheses right here. So you're talking about the square root of negative 2 squared plus 6 squared. You're just talking about these two pieces squared and add it together. And then you take the square root of that, but you don't actually have to take the square root of it because you have the square sitting on the outside. So the square and the square root will cancel. Negative 2 squared is 4. 6 squared is 36. So the magnitude of W squared is 40. All right, any questions so far? All right, so if we plug in the pieces, we have 20 over 40. And you're going to multiply that times the vector W, which is negative 2i plus 6j. Of course, that simplifies to 1/2. Distribute the 1/2, and that'll give you negative I plus 3j. All right, questions on the process before we go to the next piece. Okay, next part, the vector components of V. So I'm going to let V and W be two non-zero vectors. The vector V can be expressed as the sum of the two orthogonal vectors V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. All right. So V1 is going to actually be, what we just finished calculating. And then V sub 2 or V2 is going to be V minus V1. So V is actually going to be equal to V1 plus V2. The vectors V sub 1 and V sub 2 are called the vector components of V. All right, the process of expressing V as V sub 1 plus V sub 2 is called the decomposition of V into V1 and V2. So in other words, the breaking down of a vector into the sum of two vectors. All right, can I go up? Okay. So we're gonna let V be equal to 2i plus 4j and let W be equal to negative 2i plus 6j. Decompose V into two vectors, V sub 1 and V sub 2, where V1 is parallel to W and V2 is orthogonal to W. And as always, if I scroll up too fast, let me know. All right. So if I'm not mistaken, these are the same two vectors that we just found this for. So let me go back and check because all I see is the answer 2i4j negative 2 6j. Okay. So yeah. So that's why there's no work for this because we just did it here. Hold on. Sorry about that. I had to sneeze again. My sinuses kicking up. Guess because of the change in weather. All right. So that's going to be V sub 1. That's the first step. You want to find V sub 1, which is your vector projected on the vector V projected on the W. Or did I say that the other way around? Vector, yeah, V onto W. Okay. All right. So make sure you're good on that. That's the first step. Now, like I said, that's V sub 1. Is everybody done with the blue? I'll scroll up. All right. So finding V sub 2, all you're going to do is take 1 and subtract V sub 1 from it. And that's just a matter of distributing the negative to each term in V sub 1 and then combining your like terms. So we had negative I plus 3j. Both of those signs are supposed to change. So that'll be 2i plus I, which is 3i, and 4j minus 3j, which is 1j. All right, so that's V sub 1. And V sub 2. This is not for this. Everybody okay before I scroll up? All right. And so if you would add V1 and V2 together, that will give you V back. So V was 2i plus 4j. If you were to add both of these together, you'll get 2i plus 4j. So basically, V is equal to V1 plus V2. So the same thought process behind decomposing fractions, where you have a whole fraction and you go about doing whatever it takes to break them down to 2 or to maybe even 3 fractions. But if you were to add them back together, you will get what you originally had. So this is the same. This is what we did here. We had a vector with certain characteristics. Well, we wanted our vector components to have certain characteristics, being orthogonal to W and being it was parallel to W as well. So that's how we would find that. And that would be all that they're asking of you in this case. Make sure we're okay before we go to anything else. Everybody good? Okay. Oh, so that's it. I thought we had a word problem here. It must I might be thinking about calculus class. Let me check to make sure. Give me 1 second. There was a word problem that came along with this. But if not, I won't make one up. No. Okay, you guys are good. I mean, either I'm thinking about calculus or maybe it was a previous book. I just knew we had some word problems, but my notes stopped right there too. So, okay, that's cool. All right. So that is it for chapter 7.
Okay, so I'm gonna go. I may do tutoring with you again tomorrow.
Okay. Okay. As long as you bring your questions, we'll knock
I
them
had a
out.
question.
Uh-huh.
Do you know when the chapter 7 homework is due?
Yeah, that's what I was
Or
about
do
to
you
get.
not have a
But that's what I was about to get into now.
okay.
Yeah. So
All right, thank you.
yeah, no problem. So let's talk about that. That's a great segue into what is next. Now we mentioned where, hold on, I wrote it down somewhere. Let's see if I still got it. Okay. So we talked about the schedule moving forward. And I want to write it down here. So that was the 22nd, yeah. So we had the 22nd, 24th, 29th, 31st, and this should be April 4th. Not 4th, 5th, because we're Tuesday, Thursday. 31st, 5th. Okay, yeah, now I'm good. So right here today we did 7-7, so we closed it out. So we're done with this day. Next class will be review day. Next Thursday, you guys will be off because I'll be out of town. So we are actually looking to take our proctored test on this day right here, on the 5th, which is not next Tuesday, but Tuesday after next. Okay. So going back, before I go back into details on that, let's look at due dates. What did I put any due dates up here? No, so I didn't say anything. So I'm thinking.
Oh, that's gonna be. Oh, I think the weekend after that's gonna be the weekend out of town. The week gonna be in Florida. I'll carry my laptop with me.
Okay. All right. That's not a problem. If you want to, work on your vacation, that's fine. Or you can just, talk to me about a makeup date. Everybody, So everybody has individual situations, so I address those individually. So that's not a problem. So let's see. That Sunday afterwards is the 10th. I'm pretty sure somebody's gonna ask me for extension, so I will go for 17 when all the stuff will be due. So that includes homework and then makeup test. Oh yeah, test review will be in there as well. So now the actual proctored test, of course, will be this day. But if you just need extra time to pull up your homework grades, or let's say you want to do the test review to the 85% to get bonus points, or you need to take advantage of the makeup test, you will have until the 17th. Okay. So as far
I
as
have
due
a
date,
couple questions.
okay.
Okay, if
So-
we're done, oh, excuse me.
It's okay.
I'm just gonna
So-
say, if we're done, can I go ahead and sign off?
Yes, you're good, sir.
So 7.3, are we not doing that, right?
Yeah, don't worry about it. I'll let 7.3 be extra credit. If you
Okay.
want to do it. If you're not, it won't hurt your grade.
And so that won't be on the test, right? Because I know that
Right.
Math Lab is kind of like all the homework pushed into one. So are those questions like taken out or anything like that? Or-
I actually make the test. So
Okay.
if I didn't include it in my last class, it should be included in this one as well. So I'll look over it. But if you see something that look a little weird, look like it might be out of 7.3, just let me know. I'll make sure it's not in there. So your test review will actually project onto the actual
Mhm.
test and let you know what's on the test. So yeah, if you see something a little funky, just let me know.
All right. And then also for the test, if we're doing it, since we're doing it proctored and we take it in class with you on the 5th,
Mhm.
so do we have to finish the test within this class period?
Right.
Okay.
So we're trying to simulate the same type of in-class environment. So part of it is the timing. What else? So part of it is the timing. The other part is just the fact that I got to sit here and look at you take it, that type of thing. So that's why you have to have your camera on. Now the unproctored test and makeup is not timed. It's just the same way as all the other tests that you guys have experienced up to this point. It's just that we have to do something like this at some point throughout the class. So yeah.
Gotcha.
Mhm.
Thank you.
Yep, not a problem.
Have a good day.
All right, thanks. You the same.
Have a good day.
Thanks. Take care. Take care. As
I
always.
have a question.
Yes.
Thank you very much.
The makeup test, is that
Thank
only
you.
for those who can't take it that day? Or if you don't do well on it, can you also make it up?
Yes. So anybody want to take advantage of the makeup, whatever your scenario is, it will be open to you.
Okay, thank you.
Mm-hmm. No problem.
I also have a question.
Yes.
So I'm going to be honest, I am terrible at time management.
Mhm.
And so I had like 1.5 of my chapter 6 homework done and it cut me out. Is there any way that that could be reopened or no?
Yes. Shoot me an email so I can do it. And then I'll
Okay,
shoot your
all right.
email back. I like to have a paper trail on it because if I say I'm gonna do it now, and let's say one of the kids run by, I forget. You know what I mean?
Gotcha.
So if you send me the
Uh-huh.
email, then you'll get a paper trail or response from me saying that I actually did it. And if you don't, then I didn't do it. That type of
Okay.
thing. So yeah,
All right. Thank you.
no problem. All right. Anybody else? All right, sir. I see you. Take care. All right.